Good day, everyone. My name is Bertrand Bocquet. I'm the operations manager, and I will have the pleasure and the honor to present you the IRF SpaceLab here in Kiruna. This is the testing infrastructure of the IRF that has been up and running for the last 30 years. This is going to be the agenda for this presentation. I will start from presenting the space cluster here in Kiruna, that is no science fiction. I will also introduce you with the commercial initiative of IRF SpaceLab, a few words on what IRF is in the first place, and obviously the most important part, the testing portfolio, as well as introducing you with how we see the future for us. That is also no science fiction. So let's start from the space cluster here in Kiruna. It is first a launch base with S-Range operated by SSC and launching sounding rockets and atmospheric balloons for the last decades. It is also a space campus with Luleå University of Technology that is training 40 space students a year, and the IRF, the Swedish Institute of Space Physics, which I belong to, which research topic is plasma physics in the solar system. But Kiruna is not just a launch base nor a space campus, it is also a startups reservoir. Since 2015, there has been 11 new startups in the Norrbotten. It is also a test hub with the test bed in S-Range that allows to perform firing tests on engine and stage, as well as the IRF SpaceLab that I will present you, the space environmental testing facility of IRF. This space cluster represented in 2017 more than 450 full-time employees in Norrbotten. There is a political will to further develop that cluster from the EU, and it does this through the Reit 2021 program that aims at developing a sustainable growth in the space cluster. Has been appointed best practice amongst Steelworkers projects. So Tillväxtverket is the growth agency of Sweden. And the project is going really nicely. And the relationship with the SpaceLab is that although the SpaceLab exists since the 90s and was always open for external users, customers or partners, Reit 2021 allows the SpaceLab to have and to create more opportunities for external users. Those opportunities will lie mostly in the emerging market of small satellite launches that we see growing in Europe and that is expected to grow further over this decade. May it be for single mission launches or constellation launches, as you can see with the different colors on this diagram. In this context, SSC in S-Range is developing the launch base with the SmallSat Express program, which objective is to perform launch into orbit by 2022. This development is being implemented in cooperation with IRF, thanks to our expertise on handling payloads in clean environments. It is specifically important to consider S-Range in our context because we are so close to it, only 36 kilometers, and also only 5 kilometers away from the airport of Kiruna. But what is IRF in the first place? IRF is the Swedish Institute of Space Physics. It was founded by Bengt Ulvist in 1957, and we depend from the Swedish Ministry of Education and Research. The research conducted at IRF focuses on interaction between the bodies in the solar system and the space environment. What is worth noticing is that only 11 years after its foundation, IRF started to launch instruments out into Earth orbit. Since then, IRF has been exploring the solar system, although for today's presentation, we will focus only on the Earth orbit environment. IRF has been around. It has been around thanks to strong cooperation with international agencies like NASA and JAXA, but also like ESA for the JUICE mission. The JUICE mission focuses on the icy moons near Jupiter. And what you can see on the picture to the right is the model of the JNA instrument that will fly on the JUICE mission. And this instrument is placed into the calibration chamber that allows it to be calibrated. So this space exploration history at IRF has created IRF SpaceLab, that is the testing environment facility that is needed to perform the research in the end. So I will introduce you that testing portfolio in two different aspects. First, the testing offer in itself, and then the supporting processes that allows the actual testing offer to take place. The first testing tool that we have is TVAC, or thermal vacuum cycling, or thermal vacuum balance testing. What you're looking at with such a tool is considering your instrument, your system or satellite as a thermal object, and you want to apply thermal stress on it by cycling quickly between low and high temperatures. And you want to do it at a pressure that is representative of the deep vacuum that is in space. This deep vacuum is reached when you have removed all the atmosphere out of the chamber, and that it's only left 4 to 5 particles per cubic centimeter. In order to give an order of comparison, the atmosphere around us has 10 to the power of 19 particles in such a cubic centimeter. That is a lot of things to remove from the chamber. Then the next step for us at IRF and for our instruments is to calibrate them, because our instruments are targeted at performing measurements out into space, and it's not possible to trust the measurements if the instrument was not calibrated against a known reference. So this is what this tool is used for. The JNA instrument, again, that you can see on the picture to the right, is placed inside the chamber in front of a fully characterized particle beams, and this beam is used to calibrate the instrument. This is for us the last step before launch, and this is a research enabling tool because it allows interpretation of the scientific data after the science mission. Then we also have mechanical tests, and those are needed because of the launching phase. This phase is the most constraining on the instrument or the satellite, whatever is being developed. So what you're trying to do with that mechanical test is looking at your instrument, system, or satellite as a mechanical system, and you're reproducing the ambiances, the vibrations of the launch, and you're verifying that it is not being destroyed or damaged by such phenomena. And finally, the last big tool we have in our tool belt is this total ionization dose testing. This aims at making sure that the instrument or the satellite or the system will survive the heavy irradiation that exists out into space. So in order to do that, that is usually a destructive test, meaning that the unit that you use for testing cannot be used anymore. It will be broken down by the irradiation. You use a radiation source such as the one that is in the picture to the right, and you use it to irradiate the unit. So first what you do with the usual test process is that you perform a functional test prior to irradiation. So you make sure that the unit is working. Then you irradiate to a specific dose, and you perform a functional test again, verifying that the unit is still working. And you repeat that in a loop until the functional test fails. And then you know the accumulated dose that was needed to break your instrument or your system. So this is our testing offer as of now, already available in IRF SpaceLab. We have TVAC, calibration facility, mechanical tests, and total ionization dose testing. I will now expose you very briefly the supporting processes that allows us to perform that job. And the first is the thermal vacuum breakout. That is a cleaning process that allows the instrument, satellite, or whatever is being developed to be allowed into a vacuum chamber. Of course, we are manufacturing our instruments on site, so we have a world-class workshop that is capable of machining metal and plastics up to space standards. We have ESA certified solderers and also clean environments, of course. So now we have it. This is an overview of our current capabilities, may it be testing capabilities, TVAC, calibration, mechanical test, and TID, or supporting processes, bakeout, mechanical workshop, and clean environments. But I would like to show you also how we see the future for us in the next year. We will expand our TVAC capabilities with a new, smaller chamber. We will upgrade our TID facility. also our mechanical test topic with a larger shaker, and also upgrade the instrument calibration chamber. And we will finally add an EMC testing capability to our existing capabilities. We are developing ourselves thanks to the help of our partners that are Campus Stiftelstarna, Falcon Space Center, and Reit 2021, as well as SSC. So this is the future that we are looking at, a very complete offer in the same location that is the SpaceLab, and those capabilities are TVAC, TID facility, mechanical test, EMC, and calibration of instruments. I hope that you have enjoyed this presentation. If you are looking for more details on our capabilities, feel free to have a look at our website or send me your questions in email.